All right, the force required to stretch a piece of bungee cord was recorded in the graph below. Calculate the work done when a 60 Newton force is applied to the cord. So here our book has been very generous, and it has shown us where the 60 Newton force is. Okay, so when we apply a force of 60 newtons, we get about a 1.35 meter extension to our cord. So we just need to work out the shaded area under the graph. Okay, if we wanted to find out, let's say if we applied an 80 Newton force, then we need to go across from 80 and then find that area under the graph. Okay, or the whole thing, sorry. So here we're just looking for the shaded area because we've been told that it's 60 newtons has been applied. All right. So here it looks quite difficult to calculate that that area. There's lots of different shapes. There's some half bits and pieces in there. So in a case like this, examiners would not expect you to go through and accurately calculate the area of each little bit. Okay, they just wouldn't. What you would be expected to do is to count the squares. All right, so each square in here, let's work out what each one is. So for each square, we have a 0.5 meter extension, and we have a 20 Newton force. So therefore, each square is going to be equal to 20 times 0.5, 10 joules of work done. Okay. So if we count up our squares now, remember, if it's more than half, we count it. If it's less than half, we don't. We'll count that one, 1. We won't count that, 2, 3, 4, 5. And then if we use a bit of imagination, you could say that that bit just about fits in there. So we won't count that one. Okay, so therefore we have work done 5 times 10, so we've got 50 joules approximately. Now, I'd highly recommend, if you get a question like this on an exam, let the examiners know very clearly how you have worked this out. Number your squares, unless you have to do, 50 or so. But do something like this. Make it really clear that you know what you're doing. Okay, right. If you don't number your squares, you could just put, say, 10 squares. Just make the examiners really believe that you know what you're doing here. You haven't just plucked the numbers out of anywhere. So if you were to do this question on an exam and you counted that square, and so you did 60 joules, you get most of your marks. As long as the examiners knew what you were doing, as long as you could show it. If you just put 60 joules there, and they didn't know where that had come from, you wouldn't get anything.
What if you broke up into 2 triangles and a square?
Yeah, you could do that. Just however you're doing it, just make it clear to the examiners you know what you're doing. You have to make it clear that you are finding the area under that graph. They say all the time they reward you for good physics. Okay? Good physics is not necessarily breaking these down into each tiny little bit. That's good maths. Good physics is recognizing that the area under this gives you your work. All right? So, have a go at the next one.